Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2024, Paper 1, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1. 200 students at a school were asked how they travelled to school. The pictogram shows the results for 4 of the ways that they travelled to school. Part A says how many students walked to school. Now we've got this key down here that says one of these shapes here represents 20 students. So, and if we have a look at the walk section, you can see we've got 2 of those. So each one of those is worth 20. So altogether then, walk is 2 lots of 20 then, isn't it? It's going to be 40. So 40 students are going to be walking to school. And then part B says, how many more students travel by car to school than travel by tram to school? Well, car is, well, it's like one whole one of those 21s and half one of those. So those must be worth 10. So I guess if these are worth 20 altogether, then like each part of them is like 5, isn't it? 5, 5, 5 and 5. So for the tram you've got 20, and for the car you've got 20, 5 and 5, which gives you 30 then, isn't it? So how many more students travel by car to school? It's going to be 30 who go by car minus the 20 that go by tram, and so the difference there is 10. C says the rest of the 200 students cycled to school. Complete the pictogram to show the number of students who cycled to school. Okay, so we've already worked out that this one is 20 and this one is 30. We know that walk is 40 already. And then bus, what we've got here, we've got 20, 20, 20, and 5, 5 and 5. So what's that then? 20, 40, 60, 65, 70, 75 altogether for bus. So what's that in total then? So if we add all those up, 40 plus 75 plus 20 plus 30, what's that equal to? So 20 and 30 is 50, add 40 is 90, add 75, that's 165 in total. So if you've got 200 altogether, then if we take away 165, that leaves us with 35, doesn't it? Okay, so we need to represent 35 people cycling to school. So how are we going to draw that then? We're going to have one block of 20 then, aren't we? So one of the little squares divided into 4 pieces, giving me 20. And I've got to represent another 15 after that. So I'm going to have 3 of the little boxes then, aren't I? Okay, so just drawing those on like that. I think that's going to be 35, isn't it? 20 in the first one and 15 in the second one, giving you 35 altogether. Then finally it says the total number of students at the school is 800, What fraction of the students at the school were asked how they travelled to school? Give your answer in its simplest form. Okay, well, there were 200 people, weren't they? 200 students that were asked, tells us in the question. And if there are 800 altogether, then that is 200 out of 800. Okay, I'm just going to get rid of those zeros and cancel those out. So that's the same thing as 2 over 8. And dividing both of those by 2, you can see that's going to be the same as 1/4 then, isn't it? So 1/4 of students were asked. Question 2A part 1. Write down an odd number. Okay, we've got millions to choose from, haven't we? I'm going to go for the number 3. Okay, it's just an odd number is not an even number and doesn't divide by 2. Write down a common multiple of 3 and 17. Okay, so I guess we need to find somewhere what the 3 and 17 both go into. Now the easiest way to find that is probably just to multiply them together, isn't it? What's 3 times 17? Well, 17 and 17 is 34, and another 17 is 51. So if 3 times 17 is 51, that means that 51 divides by 3 and it divides by 17. So it's a common multiple. Now it's not asking for the lowest common multiple, but I think that actually is the lowest common multiple. Part B says write 24 to 60 as a ratio in its simplest form. So I've got 24 to 60 as a ratio. Now to cancel down a ratio, ratios cancel down pretty much the same way as fractions. So if you can type in 24 and 60 as a fraction to your calculator, get your calculator to simplify that, then your ratio is going to simplify the same way. So if I type in 24 over 60 in the calculator and press equals, you can see that simplifies down to 2/5. So that means as a ratio, 24 to 60 is going to cancel down in the same way to the ratio of 2 to 5. Okay, so 2 to 5. Question 3, complete this table of fractions, decimals and percentages. I've got 1/5 and that's equal to 0.2. What is that as a percentage? Well, you can write the first 2 digits after the decimal place as your tens and units of a percentage. So 0.2, well, it's the same as 0.20, isn't it? Which is the same thing as 20%. Okay. So you can see this working backwards here. This is the 3%, which is the unit of the percentage. So you can see it there as the second digit after the decimal place. What's that as a fraction? Well, that means it's 3/100ths, doesn't it? 3 out of 100. And then finally, 145 over 100 is 1.45. That is 145%. Okay. So again, the bit after the decimal place is the tens and units of your percentage, but we've also got this whole number part here, which means you've got 145%. Question 4, write the following numbers in order of size, smallest first. Now, they're all decimals, aren't they? But some of them have got different number of digits than others. I like to kind of pad them out so they got the same number of digits as each other, and I think that makes them easier to compare. So then I can think of them as 3,290, 3,400, 3,041 and 3,460 and rank them like that. Okay. Alternatively, you can just look at them digit by digit. So they all start with 3, so they're all the same. The next digit along is 2, 4, 0 and 4. So the smallest ones are the 0, aren't they? So that's the one that comes first, 0.3041. And then the next biggest is going to be the 2 from the first number, so 0.329. Now the other ones both got a 4, so they're the same. So we're going to have to look at the next digit along now then. So the next digit along is 0 for that one or 6 for that one. So 0 obviously smaller than 6. So the next smallest number is going to be 0.34 and the largest one then is going to be 0.346. Okay? Yeah, so you can do it that way, or like I say, you can just kind of pad them out so they've got the same number of digits and just think of them as numbers and rank those, and then your decimal is going to rank the same way. Question 5a. The diagram shows a triangle, ABC. The angle at A is 30 degrees. What does the symbol at the angle B mean? Choose from the list. Well, that symbol down at B, that's the symbol for a right angle, isn't it? Yeah, when you see a little square like that, it's a right angle. So it's going to be this one here, a right angle. Do they want us to write it down? Weird. Okay, a right angle. Part 2 says, work out the angle at C. Give a geometric reason for your answer. Well, angles in a triangle sum to 180 degrees, don't they? So the angle at C plus the 30 degrees we got at A plus the 90 degrees we got at B should be equal to 180. So then add in 30 and 90 together gives me 120. So C plus 120 is 180. And then taking 120 away from both sides, look, they're going to cancel. It's going to leave me with C is equal to 60 then, isn't it? So the angle C is 60, and my geometrical reason for my answer is that angles in a triangle sum to 180 degrees. Okay. Part B says a student works out the size of angle X in the diagram. The student says the angle is 240 degrees. Explain why the student's answer can't be right. Well, I'll tell you why, because angles at a point need to sum to 360, don't they? Because that's a full turn. And 240 plus 160 adds up to what? That's 0 carry 1, that's 400. So why are they wrong? Angles at a point should sum to 180 degrees. (360 degrees), not 400 degrees. Okay, so they should add up to 360 degrees and not 400 degrees, no. Question 6. The circumference of a circle is 17 centimeters. Calculate the diameter of the circle. Give your answer correct to 1 decimal place. Okay, so we've been given a circle and we know the distance around the edge, C, is equal to 17 centimeters. What do we want to know? We want to know D, the diameter. Diameter is the straight line that passes through the center of your circle. Now I know a formula that links C and D together. That is cherry pie delicious. Well, apple pies are too, but we only need the first one for this one. So cherry pie delicious, apple pies are too. These are the two formulas that you need to know involving circles. So good to remember those. Cherry pie delicious, apple pies are too. We need the first one though this time. We need to know the circumference formula. So we know that C equals pi D. Now we know C is 17. So I've got 17 is equal to pi times the diameter. So if I want the diameter by its own, I need to divide both sides by pi, don't I? Okay, so they'll cancel. So that means that D is equal to 17 divided by pi. Now this is a job for my calculator. So typing into my calculator, 17 divided by pi. I'm going to use the shift key to access that pi symbol. That comes out to be 5.41 as a decimal. Once it's to 1 decimal places, I'm going to have to round it off after the 4. Next digit being a 1, so I'm going to have to round it down then, aren't I? So it's going to be 5.4. Question 7. Sketch the graph of y equals 4 on the axes below. Show clearly the value of any intercepts. Now, y equals 4 is the equation of a straight line parallel to the x-axis, or another way of thinking about it is that it's a horizontal line. So we need to draw a horizontal line on my diagram, something like that. So if this is the line y is equal to 4, a horizontal line, it's going to pass through the y-axis there, and the value it's going to pass through is at 4 then, isn't it? So the y-intercept is going to be 4. Now, if you had x is equal to number, that would be a vertical line, a line going straight up, but it isn't, so it's not. So, okay. So it's a horizontal one this time. Question 8a. Insert 2 of these symbols, plus, minus, times, or divide to make this calculation correct. Okay, so we're aiming for 20. I can see 5 at the front, and I know that 5 times 4 is 20. So I guess what I need to do then is add these two together. So 3 plus 1 is 4. Now they're in brackets, so bid maths would say to do that first. So 3 plus 1 is 4. And then if I times that by 5, it's going to give me the 20 that I'm looking for then, isn't it? So 5 times 3 plus 4, 3 plus 1 in brackets is going to give me 5 times 4, which is 20. Now part B says, calculate this horrible looking thing here. Give your answer correct to 3 significant figures. Now this is just a calculator question. All I've got to do is type that carefully into my calculator and see what I get. Right, so you can see the big root symbol. So I'm going to start by pressing the square root button. And then I'm going to press the fraction key. So it's going to give me the 2 lines that are appearing under that root symbol. On the top line, on the numerator, I'm going to type in 12.9 squared plus 83. Then I'm going to press the down arrow on the little circle at the top to access the denominator below, and I'm going to type in the 5 squared there. Okay, I'm going to get it to give me the answer as a decimal, and there we go. I've got 3.15854 and change. Now with these questions, just to bank your marks, I would recommend writing the full display out first. Okay, now the reason for that is if you round it off incorrectly and write the answer down there, you'll still get the mark for typing it correctly into your calculator. Alternatively, if you type it wrong into your calculator, you'll still get the mark if you round it off correctly. So either way, it's in your benefit to write the full display down first. And then, so we said first significant figure, second significant figure, third significant figure, round off after the 5. Next digit is an 8, so we're going to round up. So our 3.15 becomes 3.16. Question 9. Here is a list of 5 numbers. I've got 14, 2, 26, 43, and 9. Find the range. Well, what is a range? A range is the highest value in your data set minus the lowest value in your data set. What's the highest value here? The highest value is the 43, isn't it? That's the biggest one. So that's going to go here. And what's the lowest number in my data set? My lowest number is going to be that 2, isn't it? Nothing smaller than the 2. So it's going to be 43 minus 2, and 43 minus 2 is 41. So this data set has a range of 41. Part 2 says a 6th number is added to the list. The mean of the 6 numbers is 23.5. Work out the 6th number. Okay. Right, well, to work out a mean, you have to add all your numbers together, and you need to divide by the number of numbers, and it's going to give you the mean. Okay. Now we're not quite doing that here, are we? We need to work backwards. So let's say I added all my numbers together, and I divided by the number of numbers, which is 6, and I got 23.5. Okay. Now working backwards, if I take the number 23.5 and I times it by 6, that's going to give me the total of those 6 numbers then, isn't it? Okay, because if I divide by 6 and get 23.5, then if I times the mean by 6, I'm going to get the total. So what is 23.5 times 6? 23.5 times 6, that comes out to be 141. So that means the sum of the 6 numbers is 141. Now I know what the 5 numbers were. They were 14, 2, 26, 43, and 9. So if I add all those up, 14 plus 2 plus 26 plus 43 plus 9, what's that equal to? So 14 plus 2 plus 26 plus 43 plus 9, that comes to 94. Okay, so the 6th number is going to be the difference between those two then, isn't it? So what do I have to add on to 94 to get 141? Well, 141 minus 94, that tells me I must have added 47 as the 6th number. Okay, so the 6th number is 47, making the total of the 6 numbers 141, making the mean of the 6 numbers 23.5 when you divide it by 6. Make sense? Hope so. Let's move on. Question 10, simplify 8j plus 4k minus 10j plus 7k. So I have got an algebraic expression made up of 2 types of terms. I've got terms in j. Look, I've got an 8j and I've got a minus 10J there, and I've got terms in K. I've got a 4K and I've got a 7K. Okay, now notice I kind of highlighted the term and the sign in front of it because the sign in front belongs to the term after it. It has nothing really to do with the term in front of it. Okay, so where I've got that minus 10J, that minus sign belongs to the 10J. It doesn't belong to the 4K. Okay, so then collecting like terms, I need to be adding like with like. So if I've got 8J minus 10J, 8 minus 10 is negative 2, isn't it? So I'm going to get minus 2J for the yellow ones. Okay, and then I've got 4K plus 7K. 4 plus 7 is 11. So that's going to give me 11K. So I'm going to get minus 2J plus 11K. That's going to be my final answer. Minus 2J plus 11K. Question 11. A recipe for cookies uses only butter, flour, sugar in the ratio of 2 to 4 to 1. Using this recipe, 160 grams of butter is needed to make 10 cookies. Using this recipe, work out how much flour is needed to make 25 cookies. So I've got this ratio of butter to flour to sugar in the ratio of 2 to 4 to 1. Okay. Now I'm going to add another thing to my ratio, and that's the number of cookies. Okay, because I want to keep track of how many cookies I've got. Now I don't know what that first one is, 2 to 4 to 1, how many cookies that is. But I do know that when I've got 10 cookies, I need 160 grams of butter. So if I make the number of cookies to be 10, then the butter I need is 160 grams. Okay, so if for 10 cookies I need 160 grams, how much flour and sugar do I need for those? Well, in order to work it out, I need to work out how many times 2 goes into 160, don't I? So how many times does 2 go into 160? Because if you look at the butter, the 2 from the butter goes to 160 when I've got 10 cookies. So 160 divided by 2 is 80, isn't it? So if I times that ratio by a factor of 80, then I should have enough of everything to make 10 cookies then, shouldn't I? So 2 times 80, already know, is 160. 4 times 80 is going to be 320. So I'm going to need 320 grams of flour. And sugar times 80 is going to be 80 grams of sugar. Okay, so that's the recipe for 10 cookies. Now I want a recipe for 25 cookies. Okay, 25 cookies. So I want to go from 10 to 25. Now 10 doesn't neatly go into 25, but I could go via another number. I could either divide by 10 and find the amount for 1 cookie. Let's do that then. Let's find 1. So we're going to use the unitary method. So if I divide the number of cookies by 10, that will give me the recipe for 1 cookie. So 1 cookie is going to be 16 grams of butter, 32 grams of flour, and 8 grams of sugar. Now that's the amount I need for 1 cookie. So if I then want to go from 1 cookie to, should have written divide there, I was dividing by 10, not timesing. So divide by 10, I'm going to get that, and then times in by 25, I'm going to get the amount I need for 25 cookies. So 16 times 25, 16 times 25 is 400. So I'm going to need 400 grams of butter. 32 times 25, that's going to give me 800 grams of flour, and 8 times 25, that's going to give me 200 grams of sugar. So using this recipe, work out how much flour is needed to make 25 cookies. Flour is that one. So I'm going to need 800 grams of flour. Question 12. The deposit for a holiday is 2/7 of the total cost. A customer pays a deposit of £618. Work out the total cost of the holiday. So if I take the cost of the holiday and I times it by 2/7, I'm going to get the deposit, and the deposit is £618. Now what I need to do is work backwards to get the original value back, which is do the opposite process. So rather than multiplying through by 2/7, I'm going to flip that over and get the reciprocal. So the reciprocal of 2/7 is 7/2, And if I times that then by the deposit, I'll get the original value back again. Okay, so what is 7 over 2 lots of 618? Now, according to my calculator, that is 2163, or £2,163 then. Okay, so if you took, just to double check, if you take 2163 and you times it by 2/7, you're going to get the deposit of 618 back again, aren't you? So that's good. Question 13. Zane drives from home to a shopping centre. The graph shows information about the journey and the time spent at the shopping centre. Okay, so we've got distance from home and we've got time. So you can see Zane sets off at 7 in the morning. He travels a total distance of 50 kilometres until he gets to the shopping centre, I guess. He spends some time at the shopping centre, so you can see his distance isn't moving. And then I don't know what happens after that because it's not clear from the diagram. But anyway, let's go through the questions. State an assumption that has been made when the graph was drawn. Well, I think the assumption is this part here. Now, this is a straight line, which means he's moving at constant velocity from his house to the shopping centre. Now, if you've ever been in a car, you know that isn't the case, is it? You're always kind of speeding up and slowing down due to traffic or turning corners or, you know, traffic lights and things like that. So you don't actually travel at a constant velocity, but I guess on average that was kind of like the speed they were going. So the assumption is here he is traveling at constant velocity. So he is traveling at constant velocity on his way to the shopping centre. Okay, so that is an assumption. It's clearly a false assumption. It's not going to happen, but it simplifies the problem down enough so we can actually sketch it. Part 2, write down the distance from Zane's home to the shopping centre. We already talked about that. If he left his home at 7 o'clock, he was 0 kilometres away from his home. By the time he gets to the shopping centre and stays for a bit, he's 50 kilometres from his home. So the shopping centre must be 50 kilometres from his home. Part 3 says, calculate Zane's average speed in kilometres per hour from home to the shopping centre. Okay, we're going to be using the DST triangle here. Distance, speed, time. What's the distance? What's the speed? What's the time? Okay, well, the distance we just worked out was 50 kilometres. Okay, speed, well, the speed is what we're trying to find, isn't it? So here was the distance here. Okay, speed is what we're trying to find. We don't know what the speed is. Time, what's the time? How long did it take him to get there? Well, if you look at the bottom of the graph here, he set off at 7 and arrived at 9. Well, it took him 2 hours to get there. It was a long journey. So it took him 2 hours to get from his home to the shopping centre. So what is the speed? Well, to work out the speed, we cover up the thing we want to find on the triangle, and then we look what we have to do with the other two. So here, speed is distance divided by time. So if speed equals distance over time, that's going to be 50 divided by 2, which is what? 50 divided by 2 is 25, isn't it? So it's 25 kilometres per hour. Then part 4 says, Zane leaves the shopping centre at 11. Sorry, that's a bit of a printing glitch. It should be 1 3/4 hours there. So the journey home takes 1 3/4 hours. Complete the graph to show the information. Okay, so this is the point where he's leaving the shopping centre, and that's at 11 o'clock. Now, if it takes him 1 hour and 45 minutes to get home, 1 3/4 hours, he's going to be arriving home at 12:45, isn't it? Which is halfway between 12:30 and 1 o'clock. So it's going to be at that point there. Okay? So what we need to do then is to join that point there at 1:45 at 0, that point there at 12:45 at 0, with that point up there at 50 and 11. Okay, so let's get a ruler out and join those up. Okay, so it should look something like that then. Question 14. 5 adults and 2 children go to a theme park. The cost of an adult ticket is £6 more than the cost of a child ticket. The total cost of the 7 tickets is £142. Work out the cost of an adult ticket. You must show your working. Okay. Now, it doesn't say here, but these sorts of questions lend themselves quite well to algebra. So if we say that the cost of an adult ticket is A and the cost of a child ticket is C, then 5 adults and 2 children go to the park means you've got 5 adult tickets and 2 children tickets. Okay, and we're told that the total cost of those 7 tickets is £142. So that tells me that 5A plus 2C must be equal to £142 like that. Okay. Now, the other thing we're told is that the cost of an adult ticket is £6 more than the cost of a child ticket. So that tells me that the adult ticket is the cost of the child ticket plus £6, isn't it? So the child ticket plus £6 is the adult ticket. Okay. So if I know that A is equal to C plus 6, then what I can do is I can replace that A there with the value of A that I've got here, this C plus 6, and then I can form an equation in C and solve it. So 5 lots of C plus 6. So rather than writing A, I'm going to write the value of A from our second equation. Okay, so this is equation 1, this is equation 2, and what I'm doing is I'm substituting equation 2 into equation 1. Okay, so where the A is in the 5A plus 2C, I'm going to write down the value of A in my second equation, C plus 6. So 5 lots of C plus 6 plus 2C is equal to 142, just writing out the rest of equation 1. Okay, so I've got some brackets which I can multiply out, can't I, just by multiplying everything in the bracket by 5. So that tells me that 5C plus 30 is equal to, plus 2C is equal to 142. Okay, so then collecting my like terms, I've got a term in C there and a term in C there, so I can add those together. 5C plus 2C, that's 7C plus 30 is 142. So then taking 30 away from both sides, they'll cancel, and that will leave me with 7C is equal to 112. And then so C is going to be 112 divided by 7. So calculator, what is 112 divided by 7? That comes to 16. So that means the cost of my child ticket is £16. And remember, from equation 2, the adult ticket is equal to the child ticket plus 6. Now we just found out that the child ticket is £16, so replacing that in, so what we're doing is substituting C equals 16 into equation 2 then, aren't we? And that's what we're doing. Substitute C is equal to 16 into equation 2. So replacing that C in equation 2 with the value we just found, which is 16. So A is 16 plus 6, and 16 plus 6 is 22. So that means the cost of an adult ticket is £22. Now, I've taken an algebraic approach to solving this. You could probably blunder your way through it numerically if you were careful. But, you know, I'm showing you how to do this algebraically because that is kind of like the cleanest, neatest way to do it as a mathematician. So, yeah. You know, if you came up with the answer a different way, then go you, but this is the way that I would do it. Question 15. The cost of sending a child to nursery is £5.80 per hour on each weekday. On Saturday, the cost is 1¼ times the weekday hourly rate. The child goes to nursery for 6 hours on a Wednesday, 5 hours on a Thursday, and 4 hours on a Saturday. The total cost of the 3 days is reduced by 5% as a special offer. Work out the cost of the 3 days after the 5% reduction. You must show your working. Okay. Right, so what I need to do is I need to work out the total number of hours, times it by the hourly rate, and work out how much the total for the week is, and then I need to reduce that by 5%. Okay? First let's find the total. Now, Wednesday and Thursday is quite straightforward. I've got 6 hours and 5 hours for those, haven't I? 6 hours and 5 hours. But this one on Saturday is a bit more of a problem because the 4 hours on Saturday count at a higher rate. It's 1.25 times the hourly rate there for the Saturday one. So what I'm going to do is going to work out the equivalent number of hours that would be then. So if I take my 4 hours that that the kids are at nursery on the Saturday and multiply it by 1.25, because that is the amount you have to pay extra. What's that going to be then? I'm just going to do that on the calculator because I've got a calculator on my desk for this one. So 4 times 1, going to use the shift key to get the mixed number button and type in 1.25 there. Press equals, you can see it's equal to 5. Now you could have done that another way, but you know, got a calculator, might as well use it. So that 4 hours on Saturday counts as 5 hours in total that you need to charge. Okay, so the total hours that we need to pay for then are going to be the 6 hours on Wednesday plus the 5 hours on Thursday plus the 5 equivalent hours on Saturday. Okay, so total hours is 6 plus 5 plus 5. That gives me a total of 16 hours. 16 hours to pay for. Right, now, it costs £5.80 per hour, so total cost is going to be 16 times the hourly rate of £5.80 then. Okay, I'm just going to type that into the calculator. 16 times 5.8, that comes out to be 92.8 or £92.80 because it's in pounds and pence. Okay, so that's the cost it would be, but then remember we've got this 5% reduction, haven't we? Okay, so we're going to do a percentage change here, a percentage decrease. So I'm going to use the triangle FOM, final original multiplier, stick your thumb on it. What are each of those things? Well, the final amount is what I want to find, isn't it? I want to find out what the cost is after the 5% reduction. The original amount is that £92.80 that I just worked out. So £92.80. And the multiplier, well, I've got a 5% reduction. So if I've got 100%, which was the cost before the reduction, minus the 5%, that is 95%. And as a decimal, that is 0.95. Okay? So I've got an original of £92.80. I've got a multiplier of 0.95. I want the final. So with the triangle, cross out the thing you want to find, and then look what you have to do with the other two. So my final amount is equal to my original amount times my multiplier. Okay, so the original amount was £92.80. My multiplier is 0.95. So what's that then? £92.80, that's still in my calculator, so I'm just going to type times 0.95, and that comes down to £88.16 then. 88.16, and that's the amount then that needs to be paid. £88.16. Question 16. Leo pays £44.98 for 26 litres of diesel. Mia puts 60 litres of the same diesel in her car. Mia has £103 with which to pay for her diesel. Does Mia have enough money to pay for her diesel? Show how you decide. Okay. Well, let's start with what Leo paid and how much he got for it. So if Leo pays £44.98 for 26 litres, then what's the cost of 1 litre? I guess what I could do is a ratio, can't I? So the litres to the cost for Leo was he bought 26 litres and he paid £44.98. Okay? So if that's the case, I can work out the cost of 1 litre by just dividing my ratio by 26. So then if I do the same thing the other side, what's £44.98 divided by 26? So 44.98 divided by 26, that gives me £1.73. So that means 1 litre of diesel costs £1.73 then. Okay. Now, Mia put 60 litres of the same diesel in her car, so we want 60 litres. Now, to go from 1 litre to 60 litres, I need to times by 60. So how much is that going to cost her to pay for 60 litres of petrol at £1.73 a litre? Well, I need to do £1.73 times 60. That's giving me £103 and 80 pence. 103.80. Now, Mia only has £103, so she's 80p short then, isn't she? So she doesn't have enough. So, does Mia have enough money to pay for a diesel? No, because it costs £103.80 for 60 litres, and she only has £103. You could also say she was 80p short, I guess. That might have been a shorter way to write it, but anyway, I've written it now. Let's move on. Fully factorise 6x squared plus 9x. Now, the word fully gives us a bit of a clue that there's more than one factor to find here. And you can see actually you've got x in both. We've got x squared and x. That both contains an x. So I'm going to factorise out an x. But I've also got 6 and 9. And those two numbers are both in the 3 times table, aren't they? So 3 is also common. So I'm going to get 3x on the outside of my bracket. And then on the inside of the bracket, what do I have to multiply by 3x to get 6x squared? Well, if I multiply 3 by 2, I get 6, and if I multiply x by x, I'm going to get x squared. So I'm going to get 2x inside the bracket. And then plus, what do I need to multiply 3x by to get 9x? Well, I need to multiply it by 3. So my solution is 3x lots of 2x plus 3. Now, if you only spotted the x or you only spotted the 3, you're probably only going to get 1 mark out of the 2 available one. Like I say, the key word there is fully. When you see that, it's a big clue that there are 2 or more factors to find. Okay, part B, x squared plus 8x plus 15. This is a quadratic, and normally quadratics factorise into a double bracket like this. Let's start off looking at the 15 on the end and think about what the factor pairs of 15 are. 15 has factor pairs 1 and 15. 3 and 5, and that's it. Okay, so I know that the factor pairs of 15 are those 2 possible pairs, but I'm aiming to get 8 in the middle, and there's only one pair here that adds up to 8, and that's that pair there, the 3 and the 5. So it's going to be x plus 3 and x plus 5 in my brackets. Okay. N is a number such that n equals 3 times 5 times k, where k is a prime number, and n is greater than 400. Find the smallest possible value of n. Okay, so this 3 plus 5 plus k is kind of like the prime factor decomposition of n, isn't it? Okay, and we know that n is greater than 400. So well, 3 times 5 is 15, so n is 15k, isn't it? So and we know that n is greater than 400, so if n is greater than 400, then 15k must be greater than 400, so k must be greater than 400 over 15 then. Okay, so 400 divided by 15, that is 26 and 2/3, so k is greater than 26 and 2/3. So presumably the smallest possible value for n is going to be the smallest possible prime number that is bigger than 26 and 2/3. Well, the next prime number along would be 29. So smallest possible k must be 29 then, mustn't it? Because that's the smallest prime that's bigger than 26. 27 isn't prime. 28 definitely isn't, so it must be 29. So therefore n is going to be 3 times 5 times 29. What's 15 lots of 29? 15 times 29, that's giving me 435. So the smallest possible value of n would be 435. And then part B says a and b are different prime numbers. Explain why a times b is not a prime number. Well, it's not a prime number because it has both a and b are factors, aren't they? And a or b can't be 1, so it's not like it's only got 2 factors, 1 in itself. So we can say that as a is not equal to 1 and b is not equal to 1, then a times b has 4 factors, I guess. It's got 4 factors altogether. It's going to have factors 1, a, b, and ab. So not prime. Okay, because primes have 2 factors only, and this one has got 4 factors. Each week, the manager of a petrol station records the average daily sales in litres and the average price in pounds of a litre of petrol for that week. The table shows their results for 10 weeks. So I've got weeks 1 through 10 for the price per litre and also the litres sold per day. The results for the first 9 weeks are plotted on the scatter diagram. Okay, so presumably week 10 hasn't been plotted. Then part A says plot the result for week 10. Well, week 10 is this one on the end here. I need to plot a price per litre of £1.46 against litres sold per day of 7,015. Now, having a look at my scale, there are 5 little divisions between 1.45 and 1.50. So presumably each one of these is 0.01. So 1.46 is going to be one little division above 1.45 then, isn't it? And then 715. Now between 7 and 715 we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little squares, which spans 50 units. So each one of those is going to be 5. So I'm going to have to go up 3 little squares above 700 then to get to 715. 7, 705, 710, 715 is going to be here. Okay, so I'm going to plot a point where those 2 lines meet. Unless my eyes have gone wonky, is here. Okay, so it's a little bit below the trend line. I think, if I drew a line of best fit, then I would probably draw it slightly above that. Part B says describe the type of correlation shown in the scatter diagram. Well, if I was to draw a line of best fit, I guess it would look something like that. Okay, yours might be slightly above or slightly below mine, but it's certainly going to look at something a bit like that. You can see from left to right, my line of best fit is sloping downwards. So this indicates negative correlation. It's pretty strong apart from that weird little outlier down at the bottom there. I'm just going to say negative because it doesn't ask me to comment on the strength, so just the type. So it's negative correlation because it's sloping downwards. Part C says, in 1 week there was a delay with petrol deliveries. Circle the most likely point on the scatter diagram for that week. Okay, so if there was a delay with the deliveries, there would have been a point where there was no petrol available, perhaps. So I'm guessing then that might explain our outlier down here. All the rest are kind of pretty much sitting like little soldiers on a line there, but that one is well below where the line is. So I'm guessing that's the outlier, and the reason is that they didn't deliver petrol until very late in the week. Part D says on the scatter diagram, draw a line of best fit. Well, I've done it already. Use the line of best fit to estimate the average daily sales when the price per litre of petrol is £1.48. Okay, so all I'm going to do there is I'm going to find £1.48, which we already worked out was like 3 little divisions then above £1.45, because each one of those is 0.01. Read up to the graph and across. So drawing up to the line and then across. So you can see that takes me to 2 divisions above 700, and we already worked out that each one of those divisions was worth 5. So that's going to be 710 then, isn't it? For that one, 710 litres. Part E says, the manager says, as the sales go down, the total amount of money we take stays roughly the same. Find evidence to support this statement. Okay, so I guess we can go back to our data at the top here. If we multiply price per litre with litres sold over the course of the 10 weeks, I won't do all of them, but maybe I'll do like every other one, then we should see if it's kind of trending up, down, or staying about the same then. Okay, so if I multiply these then, times these, I'll do 1, 3, 5, 7, 9. I don't have to do all of them, surely. So 1.42 times 740, that's 105,080. 1.47 times 620, that comes out to be 91140. 1.54 times 685, that is £1,054.90. 157 times 675, that comes out to be 1059.75. And then finally 1.61 times 655, that comes out to be 1,054.55. Okay, so we can see from the ones we've worked out, apart from this one, which was the outlier, then they're all around about 1,050 up to about 1,059. So they're all between 1,050 and 1,060. Okay, so it's kind of bouncing between those two amounts. It doesn't seem to matter what the price is. The litres sold per day kind of compensates. You end up with the same money overall. So I think there is evidence there, isn't there? So I'm going to say, apart from the outlier, the amount taken each week is roughly the same. Between 1,050 and 1,060. The diagram shows an equilateral triangular prism. Each side of the equilateral triangle is 6 centimeters and the length of the prism is 7 centimeters. Part A says, draw an accurate plan view of the prism on 1 centimeter square grid below, which I put above so you can see it next to the shape. So what is the plan? The plan view is like the bottom of the shape, isn't it? It's like its footprint. So the footprint is this face here, isn't it? Okay, so if I was going to draw that, I'd be drawing a rectangle which is 6 by 7 then, wouldn't I? Okay, 6, 7. Right, so let's draw that in. So that's my 6 by 7 rectangle, but remember you're gonna see this line along the top when you're looking down from above though, aren't you? So I'm going to show that as a line on my shape that I've drawn here as well. So my final plan is going to look like this. This is my 6 by 7 rectangle with a straight line going across the middle. Part B wants me to draw an accurate front elevation of the prism on the 1 centimeter isometric grid below. Okay, so I'm going to be drawing this front face here then, aren't I? The triangle. Okay. Now, each side is going to be the same because it's an equilateral triangle. So that side is 6, that side is 6, that side is 6. So I could just use this this isometric grid to draw it then. So if I pick a point here, look, and go 6 to the right, 1, 2, 3, 4, 5, 6 to this point here, and then count 6 along one of these diagonal lines, 1, 2, 3, 4, 5, 6 up to there, you can see it's like 6, 6, 6, 6 between them. Okay, joining up the points then with some straight lines, and then that's my front elevation there then, isn't it? Question 21. At the start of 2020, the value of a particular caravan was £25,000. The value of the caravan then decreases by 12% each year. Calculate the total loss in value of the caravan at the end of the 3 years. Okay, now This is similar to the percentage question I did earlier. It's a percentage decrease, but it's a percentage decrease repeated. It's a repeated percentage change question. I'm going to still start off with my triangle final original multiplier. Now, F is what I'm trying to find. It's the total loss of the value of the caravan at the end of the 3 years. Okay, not quite the same thing. I'm going to find the value and then I'm going to find the loss in value, I think. So I'm going to find the final value first, which isn't quite the same thing as the question's asking me, but I'll come around and look at that in a moment. I'm going to start with my original value. What's the original value of the caravan? It's £25,000. Okay, the multiplier I can work out from the decrease of 12%. So sorry, that was 25,000. Now, a decrease of 12%, if I've got 100% and I subtract 12%, that is 88%, which is a multiplier, is 0.88. So my multiplier I'm going to use is that one there, 0.88. Okay? Now, when I'm doing repeated percentage change, I need one other thing, and that is the number of times I'm doing it. It's often the number of years, and in this case, it is 3 years. Look, it comes from here, 3 years. So the number of years is 3. So just as before, if we're finding the original, cover that one up, tells me what to do with the other two. So my final amount is equal to the original amount times the multiplier. But what's different about the repeated percentage change questions is then you take that multiplier and you raise it to the power of the number of years, because you're applying that percentage change over and over again. You're multiplying by 0.88 and another 0.88 and another 0.88, which is the same thing as multiplying it by 0.88 to the power of 3. Okay? So what I'm going to type into my calculator is the original, which is 25,000, times the multiplier, which is 0.88, raised to the power of 3, which is the number of times I'm applying that multiplier to it. Okay? So I'm going to type into my calculator 25,000 times 0.88 raised to the power of 3. Now, that is going to give me the value of the caravan after 3 years at £17,036.80. Okay? Now, that is not the answer, though, isn't it? It's not asking for the cost of the caravan after the 3 years. It wants the total loss in value. So the loss is going to be the original cost minus the final cost, isn't it? So it's going to be the £25,000 it used to cost minus the £17,036 pounds and 80 pence it is now worth. So what's that then? 20,000 minus answer, because that's still in my calculator. That comes to £7,963.20. So that's how much it is depreciated by in that time. Okay, so it's lost £7,963.20 of value in those 3 years. Question 22. The width W of a car parking space is 2.8 meters. Correct to 1 decimal place. Complete the error interval for the width W. Okay. So I like to do these with a number line. So if I'm going to draw a number line for W and mark on its length 2.8, but I know that's correct to 1 decimal place. Now 1 decimal place is that now 1 decimal place more than 2.8 would be 2.9, and 1 decimal place less than 2.8 would be 2.7. Now then, presumably, if it rounds to 2.8, it's got to be closer to 2.8 than 2.7, and it's got to be closer than 2.8 to 2.9. So kind of like the interval it can lie in is somewhere in this yellow zone here, isn't it? Halfway between 2.7 and 2.8 or closer, or halfway between 2.8 and 2.9 and closer. Well, what is halfway between 2.7 and 2.8 is 2.75, and what's halfway between 2.8 and 2.9? That's 2.85. So the error interval is going to be 2.75 is less than equal to W, which is less than 2.85. Now you might be thinking, well, 2.85, that actually rounds up to 2.9, doesn't it? Because it's got a 5 on the end, and 5 or more raise the score. That's why we've got this strictly less than symbol here, W is less than 2.85. If it was equal to 2.85, it would round up, but anything up to 2.85 rounds down to 2.8. Okay. On the other end, we've got greater than or equal to, because it can be equal to 2.75, and 2.75 rounds up to 2.8, so there's no problem at that end. Okay. Yeah, so 2.75 is less than or equal to W, which is less than 2.85. Question 23, force is measured in newtons. A force of 140 newtons is applied to the surface area of 8 centimeters squared. Work out the pressures in newtons per square centimeter applied to this surface. Okay, so pressure is what we call a compound unit. It doesn't have units of its own. It's made up of bits of units of other things. And so we need to know a few different compound units and their related equations for the exams. You need to know about pressure. Pressure is equal to force divided by area. Okay, so you need to know this triangle. You also need to know about distance, speed, time. We've already done a calculation with this. And the other one you need to know is density, mass, and volume. Okay, so these are the different triangles you need to know involving compound units, but we're going to use the pressure one today. Pressure equals force over area. We've got F, we've got P, we've got A. We'll be given two. We need to use those to find the other one. Which ones we've been given? So we've been given the force of 140 newtons. It's here, look. That one is 140. Pressure. Pressure is what we're trying to find. Don't know pressure. Going to find it using the other two. And then finally area. We know area. Area is 8 centimeters squared. Right. Okay. So covering up the thing I want to find pressure. It's going to tell me what to do with the other two. Pressure is force over area. So using pressure equals force over area. Just before we go ahead, I'm going to just check the units because it wants us to have the answer in newtons per square centimetre, which means our force needs to be in newtons. It is. And our area needs to be in square centimetres, and now it is. Now, if it wasn't the case, if these weren't matching up, you'd have to do a unit change first before you do the calculation. You need to make sure it's in the units you want it to be before you do the calculation. But this is all fine. It all matches up nicely. So I just need to do 140 divided by 8 and work it out. So what is 140 divided by 8? It is 17.5. So it's 17.5 newtons per square centimetre of pressure. Question 24, the diagram shows a rectangular garden, ABCD. The region of the garden that is closer to DA than DC is to be made into a patio. Construct and shade the region for the patio. Show all your construction lines. Okay, now this is a locus question. We need to find the points that are closer to DA than to DC. Now DA is a line, DC is a line. So we need to find the points that are equidistant from two lines, okay? Now there are a number of different loci that you need to know for these exams. I'm just going to pull up a summary here. These are the four that you need to know. You need to know the locus of points that are equidistant from a point, from a line, from 2 points, and from two lines. Now this particular construction, we need to find the points that are closer to one line than the other. So in order to do that, we're going to find the points that are equidistant from two lines first, and then from there we can know which ones are closer. Okay? So we're going to use this construction here. So for two lines, the construction we need to make is an angle bisector. Now to draw an angle bisector between DA and DC, where's DA? DA is this line here, and DC is this line here. So we need to bisect this angle that is between these two lines, okay? Now, in order to do that, what we're going to do first is we're going to take our compass, we're going to set it, doesn't really matter actually how wide it is, a reasonable distance between those two lines, and we're going to draw an arc that cuts both of them, okay? So I'm going to draw an arc that cuts those two lines. So I've drawn a little bit over a quarter circle that cuts DA and DC. Okay. Next thing I'm going to do is move my compass to this point where my arc cut. DA. I'm going to put the tip of the compass there, and I'm going to draw a second arc on the diagram. Not changing the width of the compass, just leaving it as it is. I'm just going to draw an arc between the two lines. Okay, and next I'm going to move the compass to tip to this point here, where my original arc cut DC, and I'm going to do the same thing. I'm going to draw another arc, which should cut that first arc that I drew in the center there. Okay, so you can see I've got a little cross appearing in the center of my page here. So all I need to do now then is to draw a line from D going up through that point. Now that's the locus of points that are equidistant from those two lines, the DA and DC line. Now we actually want the region of the garden that is closer to DA. So we want the area that is closer to this line than this line. What do we need to do? Shade the region where the patio is. So in other words, I want this part. Okay, so this is the part that I then need to shade. Okay, so this area here is going to be closer to DA than it is to DC because the points on the line are equidistant. So if it's nearer DA than the equidistant point, they must be closer. Okay, so it's going to look something like that. Question 11. Triangles ABC and PQR are mathematically similar. Angle ACB is equal to angle PRQ and angle ABC is equal to angle PQR. Okay, that's so that you can, that you can orientate the two triangles, make sure you know you're matching like with like. So in terms of this triangle then the line between the two given angles then is that one there. The longest one, which is opposite B on this triangle, must be that one going down there, and this one then, AB, must be matching with that one there. Okay, so it's important you match up the right sides with the right sides with this question. Okay, so the perimeter of the triangle is PQR is 99. Find the length of PQ. So we want to find the blue line, which we don't have one that matches with on the other one. However, we do have two that go together. We've got this one, which matches with this one. So from that, we can work out the scale factor of the two sides. And then once I've got that, I can use it to find the matching one that goes with this one. Then we'll have two out of the three triangles. Then we'll have two sides out of the three of the bigger triangle, and we know the perimeter, so we can use that to find the missing length. I think that's probably the easiest way of doing it. Okay, so from the small one to the big one, the scale factor is going to be the bigger one divided by the smaller one, isn't it? It's going to be 45 over 12. So then QR, the yellow line, is going to be equal to 8 multiplied by that scale factor, 8 times 45 over 12. So what's that then? 8 times 45 divided by 12, that comes out to be 30. Okay, and we know that the perimeter, which is going to be a 45 that we've been given, plus the 30 we've just been found, plus QP is 99. So adding those two numbers together is going to give me 75. So 75 plus our missing side, QP, or PQ I should say, is equal to 99. So then 99 take away 75 is going to give us PQ then, isn't it? So 99 less 75, that's got a difference of 24 then. So PQ is equal to 24.
Mr. T, he's the best, helps you ace every test. Maths worries now.